Example 1. It says the data in the table below shows the results of the survey used to determine the number of adults who receive financial help from their parents for certain purchases. So it looks like it breaks it down by age from 18 to 28, 29 to 39, 40 to 49, 50 to 59, and over 60. Then you have their parents helped them with college tuition, buying a car, buying a house, and then you have the total for each of the columns. So it says if one person is selected from the survey, what is the probability that the person received financial help to purchase a home, given that the person is between the ages of 29 and 39? So what we care about is who received financial interest or support to buy a house, but we have to restrict the set that we're sitting at. So always start with the given that information. The given that information in here is that the person is guaranteed between 29 and 39. So that is the only part of the chart that I want to consider. The ages between 29 and 39. The rest of this chart no longer exists to me. Okay? Now it says what we want is that the person received financial help to purchase a home. So how many of those received financial help to purchase a home? It looks like 392 of the 29 to 39-year-olds received financial help to buy a house. And then we have to do the total, of course. The total now is not the 3109 from the entire chart. The total is the total of those who we are considering, which is the 100,000. So it looks to me like we have the probability of what we want. So the probability of them buying a home, given that they're 29 to 39, would be equal to, well, think about what you want. Those buying a house was 392, and the totals now is 1,000. Okay? Remember, the denominator is what's given, and the numerator is what you want now. Okay? Want, provided they are in the given. Okay. So, if we read it, it says write your answer as a decimal rounded to the nearest thousandth. That's 3 decimal places. Throw that into your calculator. I get 0.392. And that would be my final answer right there for that problem. So let's try example 2 now. Let's go on. It says 2 dice are tossed, one after another. What is the probability that the result is a sum of 6, given that the first die is not a 3? So I'm going to go ahead and build that chart that we always see for the die when we roll the die, where we put 1 die on the side, 1 die on the top, and then I'm going to sum them all together. Again, I've told you numerous times, put this on your note card or cheat sheet if you get one, because you're going to use this. So again, I'm just going through and I'm summing all of the numbers. I'm going to complete that chart now. Please do the same. Okay, now that we have the chart with the 2 die done, let's go ahead and reread this. It says 2 dice are tossed, one after another. What is the probability that the result is a sum of 6, given that the first tossed is not a 3? So again, it's given that, meaning we are not considering all 36 of these choices. So given that the first tossed is not a 3, so I'm going to consider this my first die and this my second die. Okay, so if I'm saying my first die is not a 3, then I have to take out the entire row that's a 3. So I want you to notice now, how many answers do I have left, or how many possibilities do I have left? Well, it seems like I have 6 across and I have 5 down. 6 times 5 is, now I have 30 is my total number of possibilities, given that the first die is not a 3. So now it says we need to look at what we want. We wanted a sum of 6. So how many 6s do we have in this chart? Looks like we have 1, 2, 3, 4 possible ways of getting 6 out of the 30 total possible choices that we have given the information. So it seems that the probability of getting a 6, given that the first die is not a 3, would be 4 over 30. Go ahead and simplify that. Would be 2 over 15. It didn't say to write it as a decimal or a percentage, so we'll write it as a simplified fraction.